Hello guys, welcome to Sunya IAS. So today we are here again at yet another session of CSAT PYQ discussion. And so today this is the part 2 video for P and C and probability. And I request you, if you haven't watched the part 1 yet, please go and watch it. And if you have done, now we can continue further on this topic. So in that video we discussed about the idea of permutation, that is the various kinds of arrangements that are possible. Now in this particular discussion, in this particular video, we will be talking about two concepts. The first concept is of combination and the other concept is of probability. Okay. So on that note, let us begin now. Here we have a sneak peek of our online and offline course, and here we are covering all the topics exhaustively. So let us talk about the questions now. So first we will be talking about the idea of combination. Okay. So yesterday we saw permutation. Permutation was nothing but arrangements, and today we are talking about combinations. And combinations basically means the idea of selecting. So combination is nothing but selection. Okay. But before we go any further on combination, we'll talk some basics about the idea of factorial. So you might be familiar with the term or you might not be familiar with the term 6 factorial, 5 factorial, 4 factorial, then we have 3 factorial, 2 factorial, 1 factorial, and also we have 0 factorial. So what is factorial? You might be aware of the exclamation mark, right, which you might use a lot in your chat, this exclamation mark. So if any number is followed by that exclamation mark, that simply means that number and its factorial. So what does factorial actually is? So if we are talking about 6 factorial, that will be simply 6 into 5 into 4 into 3 into 2 into 1. Okay. So if there is a number 6 and factorial is followed by it, so you just write all the natural numbers until when all of them will be in multiplication. Here we have 5 factorial, that will be simply 5 into 4 into 3 into 2 into 1. Similarly, we have here 4 factorial, which will be 4 into 3 into 2 into 1, right. Here we have 1 factorial will be simply 1. But interesting thing is, when we are talking about 0 factorial, 0 factorial is nothing but equal to 1. Okay, this is something you must remember. 0 factorial is nothing but equal to 1. Okay, so this was all about factorial. Now let us come back to combinations one again. And in combinations, let us talk about the idea of selection. Okay. So suppose we have 3 alphabets. We have A, B and C, and we have to select any one alphabet out of it. What are the possible ways? If I have to select one alphabet, I have 1, 2 and 3 choices, so I can select 3 alphabets. What are the possible choices I have? I have either I can choose A, or I can choose B, or I can choose C, right. So I have total 3 ways of choosing any one out of them. Similarly, if I have to select 2 alphabets, I will again be having 3 choices. What can be the choices? What can be the selections? They can be A comma B. I can choose either these two, or I can choose B comma C, or I can choose C comma A. Okay, these are the possible choices that I have. Finally, if I have to select 3 alphabets, there is only one option to do so, which means you have to select all the 3 alphabets together. This is a simple approach of doing the same thing. Now we will go by the mathematical approach or by the approach of combination. So the same idea is to be followed. But now we will follow the basics of combination. So if one has to say that out of these 3 alphabets you have to choose or you have to select one alphabet, you have to write it in this way, 3C1, which simply means out of 3 alphabets here you have to select one alphabet. Okay, so this will be the case, 3C1, this is the case. Then if we talk about choosing or selecting 2 alphabets out of the 3, it will be written as 3C2. Finally, if we say we have to choose or select 3 alphabets out of these 3 alphabets, that will be simply 3C3. So whatever I have written earlier, whatever I have done here by manual thinking, it is the mathematical way of writing the same thing. Okay, and how do we express that? So if you have the notation such as we were talking about 3 examples, we had 3C1, we had 3C2 and we had 3C3. If we have something in the format of N, C, R, out of N things, we have to select R things, the formula for that becomes N factorial because it is in the top, then we have R factorial because it is in the bottom, and then we have one more term which is N minus R factorial. This is the way of writing the combinations. So the same method we can apply for these 3 also. So for 3C1 we will have 3 factorial divided by 1 factorial multiplied by 3 minus 1, that is 2 factorial. 3 factorial and 2 factorial, so I can write 3 factorial in this way, 3 into 2 factorial. Is it okay? 3 factorial is nothing but 3 into 2 into 1. Now if I take just 3 out of it, we are left with 2 into 1, which is nothing but 2 factorial. Similarly here we have 1 factorial is nothing but 1 and we have 2 factorial as it is. When we cancel it out, we get 3. So we saw earlier what are the ways in which you can select one alphabet out of 3 alphabets, and that was 3 options we had. Similarly, if we look at the second one, we have 3C2, it can be written as 3 factorial by 2 factorial and 3 minus 2, that is 1 factorial. Here we will have 3 factorial as nothing but 3 into 2 factorial, which we did previously. Here we have 2 factorial, 1 factorial is nothing but 1. Cancel out this part, you will again get 3 choices. So out of 3 alphabets, if you have to choose 2 alphabets, even then also you will have 3 choices as we saw earlier. And finally we have the last part which says that 3C3, that would be simply 3 factorial divided by 3 factorial and 3 minus 3 would be 0 factorial. Now this 3 factorial and 3 factorial can be totally cancelled, and also 0 factorial, as we saw the value was equal to 1. So overall we will have only one way of selecting 3 alphabets out of 3 alphabets as we saw earlier. So this is the mathematical way of representing the same thing. Now we will come to the questions now, and the questions are good, so let me read it for you. First question says a selection is to be made, so it is clearly specifying the idea of selection for 1 post of a principal and 2 posts of vice principal, right? Amongst the 6 candidates which are there who are called for interview, only 2 are eligible for the post of principal, while all are eligible for the post of vice principal. Okay, so the number of possible combinations is, so we have to find in what ways you can actually select the principal and the vice principals. So overall we have 6 candidates, but out of these 6 candidates only 2 are eligible for the post of president or principal, and all of them, that is all 6, are eligible for the post of vice principal, right? Now we have to select 1 principal and 2 vice principals. So what will the process be? The process will be simply that out of these 2 people who are eligible for principal, we will select 1 principal, right? And after that we have chosen 1 person. Now this 1 person who is there is removed from this 6, and we have only 5 people left now from whom you can choose the vice principal. That is the idea which we are going to follow. So let me just write that down mathematically. So we have two people to choose from in the case of a principal. So I am choosing, out of two people I am choosing one person, right? Now I have chosen that one person for the post of principal. So I am just writing PR so that you are clear. Now you have chosen one person among the 6, you are left with 5 people now. Okay. Okay, so I was saying, here we have now 5 people left to choose from for the post of vice president. So we have 5. Out of them I have to choose how many? I have to choose 2 people for the post of vice president. That will be simply 5 C2. So these selections are for the post of vice principal. Okay. So we have to just find out this value and we get the total number of combinations that we can have. So you know the idea. 2C1, we can write it like this simply. It will be 2 factorial divided by 1 factorial and 2 minus 1, that is again 1 factorial, into multiplied by, we have 5C2, that is 5 factorial divided by 2 factorial, and we have 5 minus 2, that is 3 factorial. As you can see simply, here we have 2 factorial as nothing but 2 into 1, 1 factorial both will be equal to 1, so it is not a big deal. Further we have here 5 factorial, which can be written as 5 into 4, just a minute, yeah, which can be further written as 5 into 4 into 3 factorial divided by 2 factorial, which is nothing but 2 into 1 into 3 factorial. You can cancel out the 3 factorial part, cancel out this 2 here. So overall we will get 2 from here. Here we get 5 into 2, that is overall 20 ways are there. Okay, 20 ways will be there in which you can actually make the selection. So the correct answer in this case is going to be option number D, none of the above. Okay, so not 12. Some people confuse it always with the idea of 12. On internet, on various sources, you may find the wrong answer for it. That is, they are just not multiplying but adding the 2 values. So here you get 2, here you get 10. So instead of just multiplying 2 into 10, they actually add up 2 plus 10 and they get the answer of 12, which is a wrong answer. So you have to actually multiply. The reason, why should I open all the cards at once, right? Now we have the second question. We have the second question which says, how many different sums can be formed with the denominations rupees 50, rupees 100, rupees 200, rupees 500 and rupees 2000. We have 1, 2, 3, 4, 5 kinds of currency notes which are there, and how many different amounts of money we can create by choosing different denominations that we have to take. Out of these 5 we have to choose at least 3 denominations at a time. So out of these 5 denominations, what are the different ways of choosing at least 3 denominations? So that is, either we can choose, out of 5 we can choose 3, at least 3, or out of 5 we can choose 4, and further out of 5 we can choose all the 5, right? So these are the all ways in which we can actually select the currencies, and by choosing different currencies we can have different amounts. That is the way you have to solve it. So in this question actually it is not quite clear that whether you have to apply the concept. So it is somewhat a difficult question in that matter, because in calculation it is easy, but to figure out that combination is applied here might be difficult. Okay, so here what we can do further is that just solve it. So we have 5 factorial divided by 3 factorial 2 factorial. Here we have 5 factorial divided by 4 factorial 1 factorial, plus here we have 5 factorial divided by 5 factorial and 0 factorial. As you can see, This 5 factorial you can write as nothing but 5 into 4 into 3 factorial. This 2 factorial is nothing but 2 into 1. So you can cancel out this part, cancel out this from here. From this value you are getting not 20 but 10, I guess. Yeah, from here you are getting 10. Then further from here you can say you just cancel out this and this, you will get a 5 only. So from here you will get a 5 after all cancellation. So let me just rewrite it for you. And then we have, from here you can just cancel out this and this. 0 factorial is nothing but 1. So here we have plus 1. Okay, so we have 10 plus 5 plus 1. That is overall 16 ways in which we can create different amounts. Okay, different sums. So that is option number A is correct. Okay, chalo, now I feel like that I should open my cards, that why is there a plus and why earlier there was a multiplication. So there is a basic idea of and or. Okay, so when we have something in the form of and, we multiply. When we have something in the form of or, we add up. Okay, this is the basic idea. Now just follow what I am saying, you will be clear. So here you can see that either you want at least 3 denominations, which means either you can choose out of 5, you can choose 3, or you can choose 4 out of 5, or you can choose 5 out of 5. So since there was or, we was adding. Okay? And then in the previous question we had to make both the choices. We had to choose a principal and a vice principal or 2 vice principals. So there was multiplication. Okay, that is the basic idea. So moving on now to the third question. The third question says that a student has to opt for 2 subjects out of 5 subjects. So here you can see you have to select out of 5 subjects, you have to select 2 subjects, and the subjects are commerce, economics, statistics, mathematics 1 and mathematics 2, right? Mathematics 2 can be offered only if mathematics 1 is also opted. Okay, so one condition is being given to you. So what are the different combinations of the 2 subjects which you can opt? So in this question, as you can see, we cannot choose this particular subject until this is chosen. So this is for the time being out of choice, and we are talking about these 4, that out of these 4, how can you choose the subject? So out of these 4 subjects, you have to choose suppose 2 subjects, so that will be simply 4C2. Apart from the 4 choices, we have one more option available to us, and the other option is, there is only one option to do so, that is we can either choose, first we choose M1 and then we choose M2. So this is the only way in which mathematics 2 can be opted if we are choosing 2 subjects. So first subject should definitely be mathematics 1, only then you can choose mathematics 2. So there is only one way of choosing this particular subject. So out of choosing these 4, we have 4C2 and not and but or if you have to choose mathematics 2, if you want to pursue that either, then you can have the way of choosing mathematics 1 and mathematics 2. This is the sequence. So for that I am writing 1 because that is the only case. So either you can choose by these ways out of these 4, or you can choose that also by there is only one way, we choose both of them. So just simply add them. We have 4C2 is nothing but 4 factorial by 2 factorial 2 factorial plus 1. So actually this 4 factorial you can rewrite it like this. You can have 4 into 3 into 2 factorial, cancel out this. 2 factorial is again nothing but 2, cancel this also out. So you have 6 plus 1, that is overall 7 ways in which you can select the courses, okay, given this particular condition. So this is somewhat a level up of the previous questions. Here you have to actually satisfy this condition also. Moving on now, we have one more question which says, on a chessboard, in how many different ways we can choose or select 6 consecutive squares on the diagonals along a straight path. So in this question you have to first think about what a chessboard looks like, and to make your thinking easier, we actually have a chessboard here, right? And so what about the diagonals? So diagonals are these lines. So here we have one diagonal and here we have another diagonal, as you can see. One is white and one is black. And so he's saying that along the diagonal you have to choose a straight path. So this is the straight path along the diagonal. And as you can see, along each diagonal you can have 1, 2, 3, 4, 5, 6, 7 and 8 squares. Similarly here also you will get 8 squares. So here you have 1, 2, 3, 4, 5, 6, 7, 8. Okay. And out of these 8 squares, in how many ways you can actually choose consecutive 6 squares? It is what it is saying, right? In how many ways you can choose 6 consecutive squares? 6 consecutive squares, that is those square blocks which are adjacent to each other. Now just try to remember one question which we discussed in the previous video, in which we had the arrangement where we wanted both the girls G1 and G2 to be standing together. So if we want both the girls, so we have suppose B1 and B2 as 2 boys and we have 2 girls as G1 and G2. So instead of assuming them to be different, we assume them to be the same person. So out of 4 persons earlier which were there, B1, B2, G1, G2, now we have only 3 people to choose from, which is B1, B2 and G1, G2. They are taken as a combined entity. That is the same idea which we are going to do here. So out of this 8 blocks, let us talk about the white diagonal first. The same idea will be replicated for this also. So out of these 8 blocks which are there, we have to choose 6 consecutive. So we can assume 6 consecutive blocks to be a single block. Okay. And now we have to just choose among 3 blocks. We have to choose only 1 block. That is the basic idea which we have to follow, right? So out of the overall 8 blocks, we assumed the whole 6 blocks to be 1, and out of such possible 6 blocks, we have to choose only 1. So 3C1 will be the way in which this thing can actually be pulled off. But now as you can see here, the diagonal is not just one. So look at the diagram properly. There is not just one diagonal, there are actually how many? 2 diagonals. So whatever is true for this one will also be true for the other one. So if you can choose some squares from here, you can select some consecutive squares from here. Same thing you can do in this particular diagonal also. And so if you want to find the number of ways in which the selection can be made, just multiply it by 2. That is the basic idea which we have to follow. Okay, so this diagram is really important. So in exam you actually need not to make the whole chessboard. You can make a rough figure, just try to figure out what the idea is. So in this diagonal, out of the 8 blocks, we are choosing 6 blocks to be together at once, and we have to choose out of those 3 blocks now which are there. We have 1, 2 and this whole complete block. We have to choose only 1 block, and since there are 2 diagonals, we are multiplying the value by 2. That is the story going on behind the discussion. And the calculation part is now quite easy. We have just 2 multiplied by 3C1, which is 2 into 3 factorial by 2 factorial 1 factorial. We have 2 into 3 factorial is nothing but 3 into 2 divided by 2 factorial is nothing but 2. Just cancel it out, and overall you will get 6 ways in which you can select the diagonal. So the correct answer is option number B. And you can visualize this also. Let me just erase all of it. And here you can see what are the ways. The one way is of choosing all the 6 diagonals. Let me use yellow colored pen. Yeah, you can choose either these 6, right? Further you can choose these 6, those are in the middle. And lastly you can choose these 6 consecutive squares. So 3 choices are available on this diagonal. Similarly, you can see you can have 3 more choices on the other diagonal. Okay, so that is the basic idea. And now we will move on to the next topic. And now we have the topic of probability. See, probability is a very easy concept. There is no formula, there is nothing, just a basic idea that we have to understand, that probability is nothing but the number of favorable outcomes divided by total outcomes. This is nothing but the idea of probability. Let's say you are tossing two coins together. Okay, if you toss two coins together, what are the different options you can have? Either you can get a head on both, you can get a tail on both, or you can get a head and tail, or you can get a tail and heads, right? These are the four possible outcomes. Now if I ask you that what is the probability that we are getting both the coins as heads, so what is the probability of getting two heads? So that is simply the number of favorable outcomes divided by the total outcomes. So here the total outcomes are nothing but 4. But how many outcomes are there which are favorable to my condition? There is only one outcome which is favorable, so we will see. So the probability will be nothing but 1 by 4. Now let us take a similar idea. Okay, the similar idea would be like this, that suppose now you have a basket in which there are 3 blue balls, then you have 2 red balls, and finally you have 5 yellow balls. Okay, so the question says that out of the total balls that are there, suppose there are 3 plus 5 plus 2, that is 10 balls are there, you have to pick only one. And so in what ways you can pick a ball? So you have total 3 blue balls, 2 red balls and 5 yellow balls. You have total 10 balls to pick from. So what are the total number of outcomes? Total number of outcomes will be simply 10. But if someone simply says, what is the probability? What is the probability that you pick up a red ball? So probability of getting a red ball will be simply the number of favorable outcomes upon total outcomes. Total outcomes can be simply 10. But what about the red balls? There are only 2 red balls out of 10. So the probability of getting a red ball is simply 1 by 5, and you can also represent it as decimal as not 0.5 but 0.2. Okay, so same idea of probability. This is the way in which we are going to discuss the things. So now let us look at the question. The question might look, a bit too long, but that is not very difficult as I see it. Okay. So now we have this question which says a bag contains 15 red balls and 20 black balls. So we have red balls as 15 and then we have black balls as 20. Further the question says each ball is numbered either 1 or 2 or 3. Okay. So now it says 20% of the red balls are numbered 1. So we have red balls which are numbered 1, they are 20% of 15. Okay. So I can simply write it like this. Now you are very good with the idea of percentage. So I can simply write it is nothing but 20% of 15, which is 0.2 times of 15, and that value will be simply how much? It will be simply, I guess, equal to 6. So we have 6 red balls which are numbered 1. Then you have number 2 balls and you have number 3 balls. The question says 40% of them are numbered 3. So, okay, sorry, just a mistake. It is not, let me just calculate the value. It is not 6, it is actually 3. We have 20% is nothing but 0.2 into 15 and the value will be equal to 3. So we have 3 balls which are numbered 1, 3 red balls. Similarly, if we talk about the red balls which are numbered as 3, we can simply take, which is nothing but 0.4 of 15 and the value will be simply 6. So we have 6 red balls which are numbered as 3. So if we have total as 15, 6 are 3 and 3 are numbered as 1. So what about 2? So they will be simply 15 minus 6 minus 3, that is overall I think 6 balls will be there which will have the number of 2. Same thing we have to repeat on that side. So there we have again black balls which are numbered 1, 2 and 3. right? So it says 45 are numbered as 2. So among the black balls, 45% are numbered as 2. Let me just write that down. That is simply 0.45 into 20. The value will be simply but equal to 9. So we have 9 black balls which are numbered as 2. Further it says, and 30% are numbered as 3. So here we have 0.3 into 20. That will become actually 6 balls which are numbered as 3. So remaining we have 20 minus 6 minus 9, that is overall we have, I guess, 5 balls which are having the number of 1. So this is the overall story. So this is the scenario which I have just written down so far. And now let us read the further question. The question says, a boy picks up a ball at random. He will win if the ball is red and numbered 3, or if it is black and numbered 1 or 2. So what is the favorable condition for him to win? So we want the probability. We have to find the chances of winning. We have to find the probability of winning. Okay. So we have to find the value of P win. And what is the favorable condition for him to win? If he has to win, he must have, let me just write it down, either he must have, red ball which is numbered as 3, so he needs either a R3, or he needs a black ball which is numbered 1, so we need B1, or we can need a black ball which is numbered as 2, so we have B2. These are the 3 options of winning. Okay, as you can see, either he can get red ball with number 3, I am writing it R3, then black ball with number 1, or black ball with number 2. And what the total number of outcomes he has? He can have any ball out of the total balls. So there are total 20 plus 15, that are 35 balls which are there. What about the number of R3 balls? R3 balls are 6 in number. So let me just write down this value. We have R3 balls which are 6 in number. Then B1 balls which are 5 in number. Then we have B2 balls which are 9 in number, divided by 35. So this sum is nothing but 20 by 35. If you cancel it out by a factor of 5, it will become simply 4 by 7. So the probability or the chances of this boy to be winning are option number B, 4 plus 7. So this is a standard question on probability, not a difficult one. The idea is, if you just write down all the information provided to you, if you are correct with the idea of percentage, you can easily solve this question. Okay. Now moving on to the question number 6. This question is slightly off the topic, and it is actually requiring some thinking or brainstorming on your part. So the question says, a bag contains 20 balls. Now 8 balls are green, so we have green balls as 8. Then we have 7 balls as white, so white balls are 7. And 5 balls are red, so red balls are nothing but 5 in number. What is the minimum number of balls that must be picked from the bag without replacing to be assured that he is picking at least 1 ball of each color? Now this question is quite different in thinking. Okay, so here this one word is very important. He should be assured that he is picking at least 1 ball of each color. So suppose if that guy is picking just 3 balls, let's say. If we want to pick 1 ball of each color, total 3 colors are there. If you just pick 3 balls, there is a good chance that all the balls you pick are simply green. No choice at all, right? So you must have to think about the worst case scenario. The worst case scenario is that all the balls you are actually picking up are of the same color. Okay, so you should be aware, or you should be assured that, okay, yes, there are 8 green balls. I should pick at least 8 balls just to be assured that if there is the worst case scenario, I have picked all the green balls. So I have to pick 8 balls. So let me just erase it. You have to pick at least 8 balls just to be sure that you have picked up all the green balls, just to be sure. After that, we'll talk about the white ones. So you must be now sure that, okay, now I have picked 8. If there is a worst case scenario that I have picked all the balls of the same color, then I'll be done with green. I mean green will be there definitely without any chance. Now let us talk about the white ones. So now I started picking white ones next. So I should be assured that I have picked all the white ones. Okay. So for that also we have the case of 7. Just add 7. Right. So before starting to pick the red balls, you must be assured that okay, all the other balls I must have picked. So 8 plus 7 I have picked up these balls, and finally I can pick red ball, and even just if one ball I pick, I will be sure that since I have safely accounted for these 2 balls, now I can just pick one ball out of them and I will have all the possible options covered. That there is a good chance that now I have all the balls which are there. Okay, so overall we have 8 plus 7 plus 1, 16 balls which are needed to be picked up in order to get one ball of each color. So this question is, you know, quite off the wall, and such questions I will not recommend that you waste your time in, because these questions require a good amount of thought, and such a question might, you know, actually be wrong if you do not think in the right direction, and you may commit a blunder also. So please avoid such questions. Okay, so these are the typical red flags which you must actually avoid. Okay, so that is an art to avoid the red flags in life. Now we have the question number 7, which says that a round archery target of diameter 1 meter is marked with 4 scoring regions from center outwards as red, blue, yellow and white. Okay, so he is saying that you have an archery round, so you might be aware of this particular thing. Whenever there is a shooting target or archery target, there is a target in this form. So we have the red in center, blue, yellow and white. That is what the question is saying. I've just drawn the diagram for you. Then it says the radius of the red band is 0.2 meter. So this part you are seeing, its radius is 0.2 meter. Okay. Further it says the width of all the remaining bands is equal and the diameter of the archery target is 1 meter. So this overall archery target from here to here, the whole diameter comes out to be equal to 1 meter, or you can say the radius is going to be 0.5 meter. Right. Now this central part, this red part is 0.2 meter in radius. What about the other 3 parts? So other 3 parts are actually equal in width. Let us assume the width of all of them to be simply W, W and W, right? So this part overall is again the radius. The big radius is given 0.5 meter, so that the overall diameter becomes 1 meter, right? So I am just drawing the diagram of the archery ring, which will make things a lot easier for me. Now if you have to find the width of the bands, that will be simply just equate the 2 lengths. One can say that this radius, big radius, is nothing but 0.5 meter. One can also say that this value is also equal to 0.2 plus W plus W plus W, that is 3W. So this is the same idea of writing the radius. You can equate both of them. We can say 0.2 plus 3W is equal to 0.5. 3W is equal to 0.3, and we can say W is simply equal to 0.1 meter. So all these widths are simply equal to 1 meter, 1 meter and 1 meter. Sorry, not 1 meter but 0.1, 0.1 and 0.1 meter. Okay. This is the figure which you can draw by reading the whole description given here. And now if you have drawn the figure, the geometry part of it, if you have done that perfectly well, then you can solve the probability part of it. The question says, if archers throws arrow towards the target, what is the probability that the arrow falls in the red region of the archery target? So that is the way you have to find the probability. But the question is entirely based on geometry, right? So using geometry, we actually figured out the dimensions of the archery board. And now if you want to land the arrow at the red part, what is the probability that it lands itself in this region? That will be simply the favorable outcome divided by the total outcome. That is the basic idea of probability. So for probability, you know that probability is nothing but favorable outcome. Here outcome will be in terms of area. So this red region is the favorable area, which is red area. I am writing it. And what is the total outcome? That is the total area of the bigger target, which is the radius we have 0.5 meter. So we have total area. This probability we have to find just in terms of area. The question is not difficult. This is such a question which you can do if number one, you are able to draw the diagram correctly, which is not a big deal. After that, you must understand the probability will here in terms of area. So now you can just write down red area is nothing but pi r square, the area of a circle. What is r? It is 0.2 squared divided by total area, which is nothing but pi into 0.5 squared. Cancel out pi from both sides. Here you will get 0.2 square divided by 0.5 square. You can write it like this: 0.2 into 0.2 divided by 0.5 into 0.5. You can get rid of all the 4 decimals from up and down, up and down. You will simply get the final value as 2 into 2 divided by 5 into 5. Okay. So that will be, I think, 4 by 25. And this value, when written in terms of decimal, becomes 0.16. Okay. So the correct answer to the previous question is option number C, that is 0.16. So this is a good question, mixing two concepts from two different fields, but not a difficult one. This is something you can actually solve in exam and which you should never miss. So now we are in the last two questions of probability and permutation combination. And in this question, there is no general pattern actually. These questions are basically based on the idea of hit and trial. There is no approach. So we will just look at these questions. So first, please read it. Okay. So now we have 6 identical cards which are placed on a table, and each card has number 1 marked on one side and number 2 marked on the other side. So suppose this is the figure of a card. On one side there is written 1. When you flip it around, you get the side of 2. Okay. Then it says all the 6 cards. So there now you have actually 6 cards in total, and they are placed in such a manner that the number 1 is on the upper side for all the 6 cards. So let me just write down that. So we have 1, 2, 3, 4, 5 and 6. Now all the cards are having 1 on the top. This is how you can write it. I have drawn all the cards with 1 on the top. Further it says in one try exactly 4 cards are turned upside down. So if you are just flipping it all of them once, if you give one try, you can actually flip only 4, neither less nor more. You actually flip exactly 4 cards. So you will be flipping and they will be showing the other side, that is 2. So the question says, in how many least number of tries can the cards be turned upside down such that all the 6 cards show the number 2? So now you have to actually flip all the 6 cards in such a way that they are showing 2. But the catch is, in one try you can flip exactly 4 cards. So let us try. So suppose we try and give the try first. So we have try 1. In this try, let us try to flip these 4 first cards. So what do we get? Let me represent that by red color. We get 2, 2, 2 and 2. These 2 cards will remain as it is, right? There will be 1 and there will be 1. Now further what we can do is that we can try to further flip these cards so that we get more cards as 2. But the problem is, if we flip these 2 cards, the other 2 cards which are already 2 will flip back to 1. So that is the difficult part of it. So that is something we have to deal with very cautiously, right? So how will we be dealing with it? So now in try 2, what we'll do will be very smart. We will not flip these 2 cards, but we'll flip, just see, this card, this card, this card and this card. Now you might ask, that these cards are already okay. These 3 cards, why are you flipping them? But you will understand that in due course of time. So if we flip these cards in the second try, in try 2, you will get, here you will get 1, 1, 1, and this card will also be 1, and these 2 cards will be 2. This one will be 2 and this one will be 2. Now you might have seen that since I was not just thinking about the second try, but I was also thinking about the third try in advance. So you can see that if now I try to flip, if I now try to flip them, you can simply flip up these 4 cards and all will be equal to 2. So you have to be smart. This is the way in which we flip these 4 cards. If we flip them, we get the perfect round set. Now if we flip these 4 cards more in the third try, we will get all of them. This will become 2, this will become 2, this will also become 2, this is already 2, this one is also already 2, and this will also become 2. So now you can see all the cards are on the other side. In this way, you can get this work done in just 3 tries. That is, option number A is the correct option in this particular case. Okay, so these questions are quite random. There is no single approach. You might be lucky to get it right, you might be not so lucky, you might get them wrong also. So please deal with such questions with great caution. Okay, so now this is the last question of this topic, and by reading it, it also seems like okay, some idea of permutation combination might be there, but not so simply. So let us just read it. So there are 8 equidistant points on a circle, and how many right angle triangles can be drawn using these points? Okay, taking these points as vertices and taking diameter of the triangle as diameter of the circle as one side of the triangle. So these criteria are given. The question further simply says that suppose you have a circle which I have drawn nicely for you. In this circle you have 8 equidistant points. So you have A, let me just mark the 8 points, then you have B, you have C, you have D, E, F, G and H. These are all the points which are equidistant to each other. Now the question says that how many right angle triangles can be drawn using these points as vertices and taking diameter as one side of the triangle. So here, as you can see, I have drawn this AE as one of the diameters, and using this diameter you have to actually create various right angle triangles using these points H, G, F, D, C, B, all of these points. Using these points as vertices, you can actually draw triangles. So there is one property, and you have to draw right angle triangles. Okay, that is also something you must keep in mind. So one thing is that the property is, suppose I am making a triangle here. So let us use the blue color, let's say, and I am linking this diameter as one side of the triangle. I am linking it to G and then further linking it to E. So I am making a triangle. This triangle will definitely be a right angle triangle. So the property goes like this. Then when you create a triangle, when one of the side is diameter, so the angle found on the other side is definitely a right angle triangle. Let me put it mathematically, that the angle subtended by the diameter on any point on the circle is always a right triangle. That is the mathematical part of it. Okay, so this is the one triangle which can be formed. Similarly, 2 more triangles can be formed this way. So we have this another formation. Let me just make it somewhat better. So we can have this particular one more triangle, and similarly using a different color now, I can show you a third triangle here which goes from E till H and then back to A. So these are the 3 triangles which can be formed on the top side. Similarly, we can form same such triangles on the bottom side. So we have A, B and E as one triangle, right angled obviously. Then we have this AC and CE, this triangle as the another triangle. And finally we have one more which goes like this from D and then to E. Here is also one triangle. So if we choose AE as the diameter, we can get 6 such triangles, right? So 6 triangles we are getting if we choose AE as the diameter. Now, is AE the only diameter we can get? No, we can get various other diameters again. So let me just erase all of it and let me show you what are the different diameters which you might get. So the different diameters will be this AE we have counted, so the diameters are AE. Then the other diameter will be from B to F. So let me just make it somewhat clear, straight, right? So we have this as one diameter, which is nothing but BF. Then we have the third diameter upside down, that is GC. Then we have the fourth diameter from H to D. So this is the fourth diameter HD. Okay, so these will be the 4 diameters which you will get, and for each diameter you will have 6 triangles. So overall you will get 6 into 4, that is 24 such triangles, and that, my friends, is the correct answer to this particular question. So 24 is the correct answer. So here, as you can see, permutation combination was not applied. In fact, a basic concept of geometry was applied, which was that simply the diameter subtends an angle of 90 degree on any point on the circle. That is the basic idea which you need to know to solve this question. Obviously, such things might not be, back in your memory. It is such an obscure thing which a lot of students might have forgotten by now. It is something you study in class 10th or class 9th. But now things are too old for that, and we just simply cannot remind ourselves of the topic, of the concept. So these questions are such which you may actually solve wrong. So please deal with these questions only when you have no other time left, no other question to be done, and you are having 5 questions of the 5 minutes of the last time. Only then try to solve these questions. Okay, otherwise do not touch them. Okay, so this is the strategic aspect of CSAT. You must know which questions to solve. So as I told you, this question, this area wala question, was something you could have solved. Similarly, this question number 5, this was such a question which you could have solved. So please do not miss such questions. Okay, so probability, PNC are quite obscure topics. You can get questions which are solvable. Some of them will be non-solvable. So you must be clear about your hit rate, that out of so much questions are there, which ones you are able to solve. Okay, so on that note, we are done with the topic, and thank you guys for your persistence dealing with such, mind-boggling topics one after the other. So bye guys.